Are you ready to get started learning Unreal Engine? Let's jump right in. All right, so before we can dive in and start learning how to use Unreal Engine, we'll need to actually get Unreal Engine installed on our computers. But before we can do that, you'll need to have an account with Epic Games, the creators of Unreal Engine. Now, if you already have Unreal installed, you can go ahead and skip to the next video. Otherwise, I'm going to walk you through the 3-step process to get up and running. Step 1, you'll need to have an Epic Games account. Now, if you play Fortnite, Rocket League, or use the Epic Games Store, then you already have an Epic Games account. And you can use this same account for Unreal Engine. If not, you'll need to create one. To get started, go to unrealengine.com in your browser. Now, we're going to go up here and click on this Sign In button, where you'll be presented with an overwhelming list of options. You're going to want to click on the Sign In with Epic Games. Now, if you already have an account, you'll enter your login credentials here. If you don't, you're going to click on the Sign Up button at the bottom. When signing up, yes, you will need to input your birthday. This is a legal requirement because the same account is used for their game store, and of course for online safety in games like Fortnite. Once you've entered your birthday, fill out the rest of the information and click Continue to create your account. Step 2. We need to download and install the launcher. Once you're signed in, you can go up here and click on the Download button. On this page, you'll see the recommended system requirements on the left, but really these are the minimum requirements for working with Unreal Engine 5. You'll want to make sure you are running at least these specs that match your operating system. On the right, you'll see the licensing information. The key thing to take away from this section is that Unreal Engine is free to use. When they say free, they really do mean free. I've personally used Unreal Engine on television productions, feature films, and even VR training experiences for multi-billion-dollar corporations. Epic never charged us a penny for any of it. Now, go ahead and scroll down just a little where you will see the Download Launcher button. You'll want to download and install this. Below that, you'll see a provided video on installing the engine if you need a slower step-by-step tutorial. Once you have the launcher installed, open it up and sign in with your Epic Games account. Step 3, we need to install the engine. With the launcher open, it will likely take you to the Epic Games Store section at the start. On the left, we want to go down here to the Unreal Engine option. Clicking on this will give you a slightly different interface. To get this up and running, we'll want to go to the Library tab up at the top. Now, mine looks a little different than what a fresh one will because I already have Unreal Engine installed. On mine, under Engine Versions, you can see several cards with different numbers. These represent all the different versions of Unreal that I have installed. And yes, you can have multiple versions of the engine installed at the same time. Unreal Engine 4 and Unreal Engine 5 are both managed here and are easily identified by the number at the beginning. Now, to get this installed, we're going to click on the plus symbol next to Engine Versions. That's going to add a card with a drop-down that allows you to select which version you want to install. For this course, go ahead and select the highest engine version number available. At the time of this recording, that was 5.1.0. Then, click Install. Unreal Engine is a large program, so this is going to take a while to download and install. Be patient and you'll get this going. All right, so let's recap. In this video, we learned about setting up our Epic Games account, installing and using the Epic Games launcher, and how to install Unreal from within that launcher. Now, depending upon what project you're working on, you might actually need to be using a specific version of Unreal Engine. For example, a game studio I am currently working with is using Unreal Engine 5.0 with custom code and the plan to upgrade to 5.1 in the future. Conversely, A television team I was recently working with is still using version 4.27 because it plays nicer with the LED volume wall technology that's being used in virtual production on things like The Mandalorian or The Batman. As another example, I'm using 5.1 to teach this course and for all of my personal projects as well. Now, of course, I have all of these different versions installed on my computer at the same time. So remember, if you need more than one version, you can have it. All right, so we've got Unreal Engine installed. It's time to unpack what an Unreal project actually looks like. Now, you may have already figured out how to create a project on your own, but I encourage you to still take the time to watch this video because we're going to dive into some things that you may not have known about. In this video, we're going to go over the 3 key elements of an Unreal Engine project. So go ahead, open up your Epic Games Launcher, and let's dive right in. Our first step to creating a project is to launch Unreal. With the launcher open, make sure you're in the Unreal Engine category. We're going to go to our Library tab and click the Launch button for the version of Unreal that we want to launch. You can also click the Launch button up here if you have it set to the version you normally use. For this course, let's open up the newest version we have installed, which at the time of this recording is Unreal Engine version 5.1. Now, launching Unreal for the first time can take a while, and there are a couple of spots where it might look like it's hanging or frozen. So if it looks like it's stuck on 45% for a few minutes, don't worry. It's going to do a lot of work in the background to get the workspace ready for you. So go ahead and pause this video, go make yourself a snack, and come back when the project window is opened. All right, key element number 2, actually creating the project. The project window can be very overwhelming with all of the options available to you. Unreal Engine is a powerful beast with uses across several different industries. Once you know what you're doing and you're creating a project specifically for one of these industries, you'll know which option to select. For just starting out, I recommend going to the Games tab, where we're going to select the third-person template. Now, the reason why I recommend the third-person template for just starting out is twofold. Reason number 1, it provides a human-sized character that you can easily drop in and use for scale reference in anything that you are doing. Reason number 2, you can drop in and play as this character to run around your scene in real time. All right, so we have our third-person template selected. Now, looking at the options over here on the right, we can choose between Blueprint or C++. This is referring to the main style of code we want to start with. Keep in mind that this selection is largely arbitrary because regardless of what you select here, any project can and likely will use both C++ code and Blueprint. It's typically easier and faster to start with Blueprint, even if you plan on using C++ later in the project. Now, we'll go over what exactly Blueprint is in a later video. For now, we're just going to select that option. We'll leave the target platform as desktop and quality preset at maximum. For this learning project, we'll go ahead and include the starter content, which I'll touch on a little bit later. For ray tracing, we're going to go ahead and leave that turned off for now. The ray tracing option can improve visuals if you have a video card that supports it. If your video card has RTX or RX in the name, then you can go ahead and use it. Otherwise, ray tracing won't work on your system. This is true for any client users you deploy a packaged project to as well. Now, it does take time for the computer to prepare a project for ray tracing, so for now, even if your card does support it, we're going to leave it off for this project. We want to get into our project and working as fast as possible. Next, we need to determine where we want to save our project. The default option in My Documents might not always be the best. I like to create a folder on my hard drive specifically for my Unreal Engine projects, as close to the root as possible. This is really helpful for reducing the length of file path names. Next, we're going to pick a name for our project. For this one, we can just call it My First Unreal Project. Now, you'll notice I typed this all as one word. This is because you can't use spaces in your name. Alternatively, you can use something like underscores in place of spaces, or you can use camel casing. Camel casing is when you capitalize the first letter of each word in the phrase. How you name this will largely come down to your personal preferences. All right, once that's all set, go ahead and click Create. Now, we let the engine build our project and we wait. Now that the project is open, the first thing we're going to do here is click the little X to close it. Counterintuitive? Maybe. But we're doing this so we can learn how to open our projects each time we want to work on them. This brings us to the third key element, the project folder. Now you'll see here in our library, there is a My Project section. This lists all of the projects you've opened with Unreal on this specific computer. You can open a project from here by double-clicking the icon, but this list can grow to an overwhelming size pretty fast as you work on more projects. So let's look at another way to open our projects up. Remember how we set a project folder location when we created the project? Now we want to actually navigate to that folder on our computer using Windows Explorer or Finder if you're on a Mac. Here I am in my project folder location. In it, you can see a folder with our project's name. If we go into that folder, we'll see several other folders in a project file. Now, double-clicking this file will open our project. This will be our main and preferred way of opening projects. So it can be helpful to create a shortcut to it. If you're on Windows, you can right-click it, go down to Send To, and then Desktop Create Shortcut. Now, we have a shortcut on our desktop that we can double-click to open the project moving forward. If you're on a Mac, you'll do the same thing by right-clicking on it and select Make Alias to create a shortcut on your desktop. Now, looking back at our folder structure, you'll see several different folders. Let's do a brief rundown. Config. This is where you'll find certain configuration files that pertain to settings in an individual project. We won't be editing any of these directly, but instead we'll be looking at how to update these settings directly in the editor in a later video. Now, content is where the bulk of your project lives. This, along with config and the project file itself, are the bare bones of any Unreal Engine project. We'll be looking at how we manage this folder using the editor's content browser in the next video. Derived data cache is exactly what it sounds like. If you're ever working on a professional Unreal Engine project and you hear someone mention the DDC, this is what they're referring to. No, the DDC isn't some government agency we need to worry about. This folder is a cache storage for dynamically generated data. The contents are constantly changing, and this is one of the folders that could actually be deleted without breaking your project, because the data itself will be regenerated the next time you open Unreal. Our next folder in the list, Intermediate, is another one of those folders that can be safely deleted and automatically regenerated. Think of this folder as your project's temporary folder for local user data. Keep in mind that this folder does contain your locally compiled shaders, so while you might not include this folder in source control or when sharing the project folder, deleting it does mean that Unreal will have to compile shaders again the next time you open it. The next folder, Saved, is your local user-related content. This means any local user settings, as well as where things like your screenshots and rendered videos will be saved. We'll go into that more in depth later, but this is another folder that you generally would not include for things like sharing the project or uploading to source control. All right. Now you should be a little bit more familiar with Unreal Engine projects. Congrats on making it through one of the more boring topics, but understanding the structure of projects is essential knowledge if you're serious about working with Unreal Engine. To recap, we looked at how to launch Unreal Engine and create a new project using the third-person starter template in the Games tab. We looked at how to open an existing project and create a shortcut to our project file. And finally, we deconstructed the project folder to see what makes an Unreal Engine project tick. All right, so we've got a project to work with, and now it's time to get familiar with using the editor. Unreal Engine is a powerful piece of technology, and that can make it absolutely terrifying when you first load into it. I've had hundreds of my students over the years tell me that they wanted to learn Unreal Engine on their own, but as soon as they opened the editor, it was so overwhelming that they immediately just closed it and never came back. In this lesson, I'm going to teach you how to navigate the interface inside of Unreal Engine by showing you the 6 major elements you need to understand in order to get started. By the end of this video, you'll look back in awe at how easy it actually is to work with. All right off the bat, let's jump into the bread and butter of the editor. The viewport. This is the 3-dimensional stage where you'll be building out your world. All of your models, characters, and everything else will exist within this stage, which Unreal refers to as a level. And we'll dive deeper into what that means in a later video. Now, there are 3 different options for navigating the camera around the viewport. Option number 1, the WASD method. This is actually my personal favorite method. Now, if you're familiar with PC gaming, you'll feel right at home with this one. What we're going to do is hold down the right mouse button to activate this method, and while you're holding down that button, press W on your keyboard to move forward, press S on your keyboard to move backwards, press A to move left, and press D to move right. While holding down the right mouse button, you can also move your mouse to rotate the camera's look at direction around. Using a combination of rotating the camera and using WASD to move, you can get around anywhere. Option number 2, the Unreal method. This is the movement scheme that Epic developed in its earliest versions from back in the 90s. To use this, we can hold down the left click on the mouse and move your mouse up to move forward along a completely horizontal plane, or move your mouse down to move backwards along that same plane. Moving your mouse left and right will rotate the camera around. Holding down both the left and right mouse button at the same time, you can pan the camera around like this. And of course, just like with the WASD method, holding down just the right mouse button lets you rotate the camera's look at direction around. Keep in mind that using this method, the left click will always move along that horizontal axis, regardless of where your camera is actually looking at in the vertical axis. To move towards your look at direction, you'll need to use the WASD method. Option number 3, the Maya method. If you're used to working with 3D modeling software like Maya, this one is going to make a lot of sense to you. Holding down the Alt button on your keyboard or Option on a Mac, you can use the left mouse button to orbit around the center of your viewport. You can use the right mouse button to dolly in and out. And you can use the middle mouse button to pan around. Now, one final thing that all of these different methods have in common is that you can use the scroll wheel to zoom in and out. The scroll wheel can also be used to control the speed of your camera movement by using it while you're actively in the process of moving using the WASD method. Now, I personally use all 3 of these methods depending upon what I'm doing at any given time. I tend to favor the WASD method, but there are times when I want to orbit around a specific area or I only want to move along a 2-dimensional plane. Next, let's have a look at the second major element, the outliner. Over here to the right of the viewport and on top is the outliner. This is a list of all the assets that are currently in your level. This includes models, lights, blueprints, and everything else that make up a level. All of these things Unreal refers to as actors. So every actor in a scene will show up here. If we click on one of these actors in the list, you'll see it highlighted in the viewport. With an actor selected, if you hit F on your keyboard, it'll actually move your camera to that actor. This is called focusing an actor. And if you were unaware, this actually works in nearly all 3D software. So if you're a modeler or sculptor and didn't know this, you'll give it a try. You'll also see that many of these actors in the default scene are organized into folders. You can move these into a different folder by dragging and dropping it. Alternatively, you can right-click and go down to Move To and select an existing folder to move it to. New folders can be created in the Move To dialog or by clicking this New Folder button up here. All right, next we're going to look at the Details panel. If we were to click on one of the items from within the viewport or in the outliner, you can see that the Details panel gets populated with all kinds of parameters. What shows up here is largely dependent on the type of actor that you actually have selected. For example, with this cube selected, we can see options for things like the mesh, the materials, and the physics. However, if we come up here and click on this directional light, the details panel now gives us parameters to control things like the intensity, the color, and the source angle. We'll go deeper into what all of these parameters do on a specific actor type when we go over that actor type. For now, make note that all of the settings that you can change on an actor in a level will be found in this details panel. All right, the next interface element that we want to look at is the toolbar. Located directly above the viewport, the toolbar contains several items that help you craft your world. This includes things like the editing mode. Unreal actually has several different editing modes that change the way your interface looks and behaves depending upon what mode you're in. Selection mode is where you'll spend probably 80 to 90% of your time. But there are other modes that allow you to work with things like landscapes, vertex painting, and even 3D modeling within the engine. We'll go over each one of these modes in detail on the full course. Next to the editing mode, we have the Create button. This allows you to add specific kinds of actors into your level. Your options are organized neatly into folders, but once you click on this button, you can also just start typing to search what you need. The toolbar contains buttons for working with level-related blueprints, as well as a button for quickly creating sequences, which are how you work with cinematics in Unreal. The toolbar is also where you'll find your play in editor controls, which we'll go into that in a later video. But for now, just know that you can click the play button to drop in and play. And then you can hit escape on your keyboard to exit. Platforms and settings we'll go over later. Just above the toolbar, you'll find the menu bar. File, edit, help. This is all pretty standard fare like any other software. One thing I do want to point you to is the window option. This menu contains all of the various panels that Unreal Engine has. There are a lot of things in here that we'll go over in dedicated videos in the full course, but the important thing to note is that if you ever lose a panel, this is where you go to get it back. Let's say you accidentally close your details panel. To get it back, you would go to Window, Details, Details 1. Clicking on this pops it back into place. Notice that there are 4 details panels in the list. This can be useful if you ever need to have a second floating details panel somewhere. Also note that you can dock any of these windows anywhere by clicking on the title tab and dropping it into a spot. As they say with any kind of creative endeavor, content is king, which is why our final and second most important interface element we're going to look at is the content browser. Now, if you remember deconstructing the project folder in the previous video, I mentioned that the content folder was where the bulk of the project actually lives. The content browser is how we actually access that content inside of the editor. To access the content browser, we can go down here to the lower left of the viewport and click on this Content Drawer button. This will expand our content browser as a temporary drawer element. Clicking outside of it will make it go away. You can also use the shortcut key of Control Space or Command Space on a Mac to pull it up. Now, I personally like to keep my content browser up at all times when I'm deep into crafting a scene, which you can do by going over here and clicking on this Dock in Layout button. To the left, you'll see a hierarchy of the folder structure. And to the right, you'll see the contents of the folder that you're currently in. Since we started with the third-person template and the starter content installed, you can see all the folders related to those in our content browser. Digging down into one of these folders, such as level prototyping, and then into meshes, you'll see some familiar-looking 3D models. These are representative of the models that the starter level in our viewport is made from. At this point, the Unreal Engine interface should be a lot less intimidating. There are a lot more aspects of the interface that we'll cover in the full course, but just knowing how to work with these 6 major elements puts you over 50% of the way there to mastery over the interface. All right, so you're comfortable with basic navigation around the editor. Now let's go ahead and take a look at working with content inside of the editor. As they say, content is king. And in the case of Unreal, without content, we just have an empty scene. So let's jump into my 7 keys for working with assets in our scene. The first key is to have a scene to actually work in. With the third-person starter template, you can see this playground in front of us when we first open the editor, but we'll actually want to create our own level to start working with. To do that, go up to File, New Level, and you'll get a dialog box with a few options in it ranging from open world to a blank empty level. We want to select Basic for this exercise. This is going to give us a bare bones level to work with that already has some lights and a sky in it. And with Basic selected, we'll just go ahead and click Create. Now, if you made any changes in the template level, then it's going to ask you if you want to save. Since we don't really want to mess with the starter template level, click on Don't Save. All right, with our new level open, the second key is going to be to add some content. So we're going to look at this in two different ways that we can do this. First, we're going to click on our Quick Add button in the toolbar. That's the little cube with a green plus symbol on it. This is going to give us a drop-down with a lot of options, and you're going to get very familiar with many of these options later in the full course. For now, let's go down to Shapes, where we can click and drag a cube into our scene. Once you drop it in, you'll see this widget with some arrows. This lets you move the object around, but we'll actually dive into that a little deeper in the next step. First, I want to show you the second way of adding content to your scene, the content browser. Remember, we can click the little content drawer button in the lower left, or we can use the shortcut Control-Space to bring up our content browser. I'm going to go ahead and click on Dock and Layout since I'm in the content adding mindset right now. From here, let's drill down into our starter content folder and then into the props folder. In here, you'll see all sorts of props that can be added to the scene. What we're looking for right now is pretty much anything with the word static mesh at the bottom of the thumbnail and at the top of the tooltip. This is a 3D object that we can use in the scene, just like the cube we added earlier. This leads us to our third key, which is transforming assets. Just like the cube, our chair has an arrow widget on it that will let us move it around. This is called the Move widget, and it's part of the Transform tools. If you work with any 3D modeling software, then you'll be familiar with the 4 tools in this set. Select, Move, Rotate, and Scale, with the corresponding shortcut keys of Q, W, E, and R. Now be sure to check out the cheat sheet below the video to help you remember those hotkeys. Now let's get back to the Move tool, which can be activated with W. The Move tool has 3 arrows, each representing a planar axis in 3-dimensional space. You can click and drag on any of these arrows to move an actor along its axis, or you can click on one of the little squares to move in 2 axes at once. Clicking in the very middle of the widget will let you move in all 3 axes at once, but I find that I spend most of my time using the square to move in a 2-dimensional planar axis when moving. Now, another cool thing that you can do is if you hold down Shift while you're moving an object, it'll actually move the camera along with it. The next transform tool that we're going to look at is the Rotate tool, which is activated with the E shortcut. Also notice that as I change tools, the highlighted tool in the viewport toolbar changes as well. These also act as buttons if you happen to forget the hotkeys, which you won't, right? The Rotate tool also has 3-axis control that you can rotate around. Hitting R will activate the Scale tool, which you can use to manipulate the size of an object. The Scale tool can be used in an individual axis, but this is one where you'll likely be using the center to scale the object uniformly most of the time. If you ever need to get granular when lining things up, you can access traditional orthographic viewports by going up to the button in the far right corner. Then you can maximize that with the same button. As an example, I'll go over here to the top viewport and maximize it. I'll then find my chair in the outliner, hit F to focus it, use the scroll wheel to zoom in closer, right-click and drag to move the viewport around, and then move my chair to line up with the cube. I can then click the button to go back to my 4-up view, then maximize my perspective viewport to continue working. Now, one more quick thing to understand about transforming assets is world space versus local space. World space, notated by the globe symbol up here, means that no matter what the rotation, the object will always be manipulated in relation to the world. Local space, on the other hand, which we can toggle to by clicking on this button, means the manipulation of the object will be relative to the object itself. Now, as you get more comfortable with moving objects around in the viewport, you'll find yourself toggling between world and local space a lot. Now, you've probably noticed that as I've been moving, rotating, and scaling things, that the adjustments are happening in a stair-step fashion. This is actually because of our fourth key, snapping. Snapping is the act of applying constraints to a transformation. For example, we can have something move 10 centimeters at a time, or we can have something move 100 centimeters at a time. And on that note, Unreal Engine uses the metric system, where one Unreal unit is equal to 1 centimeter. Looking up here in the viewport toolbar, we'll see the snapping options for move, rotate, and scale. For the icon on the left, you can click it to toggle it. Blue means that snapping is enabled, and gray means that it's disabled. The number on the right is the value of the snap. Clicking on this will change to a drop-down so that you can change that value. Now, while you can toggle snapping off to get some good free-form control, remember that snapping is your friend when it comes to building a scene. Whether you're working on a digital set for a film or an environment for a game, snapping is one of your most valuable resources. In the industry, we call this working on the grid. Now, another cool trick with snapping is that you can hold down the V key on the keyboard to snap to a vertex on another object. This lets us do things like snap our chair to be centered on this cube. But what if my cube was rotated and I wanted my chair to be in the same orientation? That's where surface snapping comes in. By going up here to the surface snapping icon, I can turn on surface snapping. With rotate to surface normal turned on, if I hold down V, I can now snap not only to the cube's face location, but its rotation as well. Now that actually brings me to the fifth key of working with assets, grouping. Two or more objects can be simultaneously selected by holding down Control or Command and clicking on them. Then you can group them by hitting Control and G or Command and G on a Mac. Move them around as one, and then you can hit Shift and G to ungroup them if you need to. Now this actually ties into the number 6 key that I wanted to talk about, which is duplication. An object can be duplicated in the viewport by holding down Alt or Option on a Mac and then dragging it out. This is useful because it's much quicker than continuously dragging a new copy out from the content browser, and it's more accurately controlled than just doing a copy and paste. Both of which you can do if you wanted to, but getting comfortable with the Alt-Drag duplicate is going to be essential if you want to speed up your workflow. An example of using these two keys together would be adding a table with chairs around it, grouping that up, Alt-dragging out a copy, ungrouping it, tweaking the chairs a little bit, then grouping it back together again. Doing this, you could quickly build out an entire restaurant with subtle variations in chair placement. Now, our 7th and final key is to make use of the Details panel. Selecting one of our objects, if we look over at the Details panel on the right, take note of the Transform section. Here you'll see the location, rotation, and scale of the object represented in numerical values. This can be really useful for getting very granular with the transformation of an object, allowing you to get some very exact values. For scale, take note of the padlock icon, which allows you to toggle uniform scale on and off. With it off, you can scale a specific axis individually. And with it on, everything will scale uniformly, just like if you click the center of the scale widget. Mobility here for 3D models mostly relates to if the object is going to be moving or not. We'll cover that more in depth later in the full course. Below that, you'll see where you can actually change the static mesh. I could, for example, drag out a copy of this cube, then click on the chair, where I will then click on this little folder with a magnifying glass icon to locate the chair in the content browser. By the way, you can also do this with the shortcut of Control+B. And now if I click back on the cube, I can click this arrow and a circle icon to assign that chair to this mesh actor. Notice that the mesh changes, but it's white now instead of chrome and yellow like the other one. This is because the actor itself is the same, as you can see by the same name of cube in the outliner. But we've changed the mesh that it's actually referring to, that it's actually referencing. The material is still the same basic shape material from before, just like with this other cube. Now we could actually click on the chair, use the Find in Browser button to locate the material, then go back to the cube that is now a chair and assign that material. And this is where the Details panel lets you update individual parts of an actor. You likely won't find yourself doing that exact step when you could just alt-drag a copy of the chair itself out, but where this does come in really handy is when you want to change the material on something. As an example, let's navigate to the Starter Content Architecture folder. We're going to drag this wall 400 by 400 out into the world, and we'll go up here to change our snapping to 500 centimeters. Then we'll drag out 2 copies. Now go into the Starter Content Materials folder, where you'll find all kinds of material options that you can play around with assigning to these 3 different walls. Another quick way to change the material on something is to just drag from the content browser and drop it right on top of the model. Alright, so now that you know how to work with content to lay out a scene, let's have a look at one of the most important aspects of 3D digital art: lighting. Lighting in Unreal is an art form in and of itself, and there are some powerful tools available to us. In the full course, we'll be going over an entire module's worth of content on lighting. There's just so much to cover when it comes to cinematic lighting. But in this video, I want to get you quick started with a high-level overview so that you can get in and start adding lights to your scene. So let's have a look at the 5 types of lights in Unreal Engine. The first light that we're going to look at is the directional light. Now, the directional light can most easily be thought of as the sunlight of a scene. If we create a new basic level, we're presented with a starter scene that already has a directional light in it. If we rotate our camera around, we should be able to actually find the sun in the sky. Over here in the outliner, under the lighting folder, we can find the directional light. Also note that the sky sphere is an actor that renders our blue sky. The volumetric clouds render the clouds, and this sky atmosphere is a special actor that ties it all together. We'll go over all of that in great detail later on in the full course. For now, let's just laser focus on this directional light. If we select the directional light and rotate it, we'll see the lighting in the level change in a time of day fashion. We can even see that the sun is now lower in the sky. If we take it a step further, we can actually capture a morning golden hour, and even a step further than that to capture a sunrise or a sunset. Any further and the map goes black as it translates over into nighttime, which has some special case considerations that we'll dive into later. Bringing the sun back up, let's take a look at the Details panel. Under the Light category, let's have a look at this intensity parameter. You'll see a value of 6 lux. Now, lux is a measurement of illuminance per unit area. And if you're familiar with the lux measurement, then this can make Unreal's lighting a little confusing for you. In the real world, the sun has a lux value ranging from less than 40 all the way up to 120,000 in direct sunlight. And this depends on many factors such as time of day or the amount of clouds in the sky. Pair that with the fact that the sun is 93 million miles away from the Earth and the Earth's atmosphere diffuses some of that solar radiation. Unreal's internal gears are fudging some calculations and doing some magic behind the scenes. Keeping that in mind, you should pretty much ignore the lux aspect of the value here and just get comfortable with being creative with the art direction. The default value in a new basic map is 6. Many of us in the game and film industries have found 20 to be a solid average value for this. The important thing here, when you're getting started, is to just not overthink it too much. Now, next, let's have a look at the skylight. The skylight is a unique light that serves a very specific purpose. If you're familiar with HDRI lighting, or you're a 3D artist familiar with software that provides default lighting environments, such as Substance Painter or Marmoset Toolbag, this is what the skylight does in Unreal. It essentially acts as the HDRI lighting environment. By default, how this works is by capturing what it sees in the sky, including the sun, the clouds, and the color of the sky itself, to create a high dynamic range image to cast light out into the level. This is really great for outdoor environments. But you can also plug an actual HDRI image into the skylight to use that instead. To demonstrate that, let's create a new level but this time we're going to select Empty Level. This is going to be a black viewport with nothing in it. So let's go ahead and drop a chair in from the starter content. Then let's go up to our Quick Add button, down to Lights, and then drop a skylight in. Notice how the chair is completely black. That's because there is no sky, sun, or clouds for the skylight to capture in order to create that HDRI environment. So instead of trying to capture what's not there, let's just define our own HDRI image. To do this, go over to the Details panel with the skylight selected, and we're going to change the source type from Captured Scene to Specified Cube Map. The starter content provides us with an example HDRI cube map to use, so we'll click on the dropdown and then we'll select it. Notice how suddenly our chair is lit. Double-click on the thumbnail to see the image that is actually being translated to these light values. The brighter parts of the image are brighter parts of the light, just like the darker parts of the image are darker parts of the light. And this equates to a giant light with varying values surrounding the level in a 360-degree sphere. Take note that we can adjust this source map cube angle to rotate the image around, which gives us some different lighting. The intensity scale will adjust how much of that light is actually being contributed. With a default value of 1, you're going to be working with some really small numbers here. And then light color will adjust the tint of the HDRI image that's produced. And of course, all lights have an Effects World checkbox that lets you toggle them on and off. All right, next, let's start diving into artificial lights. First on that list is going to be the point light. To start, I'm going to grab this floor from the Starter Content Architecture folder and then scale it up to get a bigger area to work with. Then I'll use the Quick Add to drag out a point light. Now, a point light is an omnidirectional light that radiates light outwards in a 360-degree sphere. Think of this like a light bulb, which should be easy to do based on the icon that it uses. Now, the size of the sphere of influence is controlled by the attenuation radius. This value tells the light how far it can travel, but not how far it will travel. That's actually controlled by the intensity of the light through a science called inverse squared dynamics. We'll cover that in depth in the lighting module of the full course, but for now, just think of the attenuation radius as an option that you can use to clamp how far the light can actually travel. With a larger attenuation radius, notice that as I change the intensity, it also affects the distance that the light travels. You'll also see that the value of intensity on the point light has a CD at the end. This stands for candelas and is the unit of measurement that Unreal uses for artificial lights. This is a more true-to-life measurement for you to use. Now, 8 candelas is equal to roughly 100 lumens if you're more familiar with that unit. Alternatively, you can type intensity into the Details panel search box and change the intensity units to lumen if you're more comfortable actually using them. Light color does exactly what you would expect it to and lets you change the color of the light. You can get as wild as you want here, but for more realistic lights, you can actually check the Use Color Temperature option and then use the color temperature values to get warmer or cooler lights. These are pretty accurate to real-world values. The next light that we're going to look at is the spotlight. Now, if you work in film or photography, this one is going to feel real familiar to you. We can grab this from the Quick Add menu as well. And just like the point light, intensity, color, and temperature all work the same. The attenuation radius also works the same, but because the light is not omnidirectional, it's actually represented by the length of the cone. Now, the width of the cone is controlled by this outer cone angle. The inner cone angle gives you an additional cone inside of the larger one that focuses the light a little harsher. Learning to use both cones together to get good results is an art form that we'll cover in full detail in the full course's cinematic lighting module. Next, let's look at our final artificial light type, the rect light. Short for rectangle, the rect light is a planar light source that simulates light coming from a rectangular surface, such as a television screen, a computer monitor, or even a rectangular light fixture. Also found in the Quick Add menu, the intensity, color, and attenuation radius are just like the other lights. The key settings for a rect light are the size and the barn door. For the size, you use the source width and source height to shape the rectangle. These units are in centimeters, of course. And then you can create a barn door effect with the barn door settings. Adjusting the angle, we can start to box the light in. Then we can use the length to make the doors longer. Now, while we can make what looks like a really good softbox shape, the barn door settings are actually more useful for creating some hard shadows, almost like a light coming through a barn door. Alright, now you're aware of what lights are available to use inside of Unreal Engine. Like I mentioned, cinematic lighting is an art form in and of itself, which is why we'll be spending a lot of time covering it in the full course, with an entire module of videos dedicated to just that subject by itself. Computers have been a big part of our lives for decades now. We all know how to use Control-S to save, or at least how to go to File, Save. But one of the questions I get all the time is, I saved my level, how come I lost half my work? Well, that's because Unreal isn't just one file. It's an entire ecosystem. But once you understand the 3 keys to success when you're saving your work, you'll never have that problem yourself. The first key is to understand levels versus actors. Let's break it down. A level is the scene that you actually see in your viewport. You'll also hear this referred to as a map or a set, depending upon your industry. You'll get used to hearing me call it a scene. These all refer to the same thing. The level itself is like a container for your layout. Everything inside of the level exists somewhere in the content browser or in the engine code for certain base elements like lights. When you hit Control-S, it's going to save the level and just the level. This saves the layout of any actors in it, but does not save the actor itself if you made any changes directly to an actor, such as changing the color of a material or the default material assigned to the mesh. Let's go ahead and create a new basic level. Then hit Control-S to save it. You'll get the Save Level As dialog. Right-click on the content and select New Folder. Then just name it My Stuff with no spaces. Now we'll set a name for the map. I'll call mine Saving Tutorial, and then we'll click Save. I'll use the Quick Add button to add a couple of cubes, and then hit Control-S to save again. Now, each actor in a scene is self-contained. While you can move, scale, rotate, and update the details of an actor in a scene, the base actor itself in the content browser keeps its defaults and is saved in the content browser. Remember how we dragged a chair into our scene and then manipulated it? If we were to drag the chair in from the content browser again, we'll get the original chair. We can then manipulate it in a different way. If we save the level, then both versions of the chair will be saved in that layout, but the original chair in the content browser remains unchanged. This is because the actor assets are saved independently of the level that they're in. To demonstrate, let's navigate to the chair in the content browser. Hit Control-D to make a duplicate of the chair so that we're not messing with the original. And if you select the thumbnail, then hit F2, you can rename it. I'll call mine SM_tutorial chair. Now, if we double click it, it'll open up the static mesh editor. In this editor, you can see a viewport with a showcase of the asset in it on the left and a details panel on the right. Let's go ahead and change the material. We can click on this drop down and see a list of all of the materials in the project. You can also search for a material. I'll type in gold and assign this one. Notice how the thumbnail in the browser has an asterisk on it. This means that the asset has changes and it needs to be saved. To save our new chair, we'll have to click the Save button in the asset editor. Now, if we drag our new chair out into the scene, you'll see it has the new gold material on it. And the original chair still has the original material on it. Now, if we go into the Starter Content Materials folder, let's find another material. How about brushed nickel? We can drag and drop that onto the slot in the editor. Notice that it changes in the level. However, if we go up to this Browse button in the asset editor to find it in the content browser, you'll notice it still has the asterisk. This means that the asset itself is not saved even though you see it in the editor. So even if you saved the level, if you were to close Unreal now without saving the asset, then when you came back, the chair would be gold again. Remembering to save in different places can be kind of cumbersome, but Unreal does provide a solution to make it easier, which brings me to the second key, using Save All. If you go to File, you'll see several save options, including one called Save All. The hotkey for this is Control-Shift-S. Now, if you remember no other shortcut, remember this one. This will save you more than you know. Say it out loud with me. Control-Shift-S. Control-Shift-S, or Save All, does exactly what it says. It saves everything. It saves the level layout you're working in, all of the settings inside of it, and all of the actors that you've updated. When you're working on a project in Unreal Engine, you'll want to shift your mindset away from the traditional Control-S to save, and get comfortable with Control-Shift-S to save all. Now, real quick, while we're on the topic, I want to bring up something that's new in Unreal Engine 5, the concept of one file per actor. Now, you may hear this phrase thrown around a bit in various conversations, but what does it actually mean? Didn't we just talk about how all actors are their own independent files in the content browser? Yes, we did. But one file per actor is actually referring to something completely different. This really pertains to working on group projects, specifically related to source control, which is something that we'll talk about in full detail later in the full course. Traditionally, only one person on a team could work on a level at a time. They would have to check out and lock everyone else out of that level while they were working on it. Unreal Engine 5 changed that by introducing the one file per actor system. What this means is that each actor that exists in a level has all of its level-related information, such as location, scale, and rotation, saved in an external file. Now, these external files are more like hidden files with gibberish names that exist only to store that information outside of the level itself. You don't need to worry about tracking them or working with them directly. All that happens automatically behind the scenes. Just know that this allows more than one person to work on the same level at the same time, which is something that you couldn't do in Unreal Engine 4.
Another convenient way to save everything is by coming down here and we can see this for unsaved. So this little button right here, if we click it, it's going to bring us up this dialog that lets us save content. Now we can also find this down in the lower right of any of our editor windows. We can see right here, same thing, and it's going to give us a list of everything that this wants to save. So this is a more visual version of the save all functionality where we can turn certain things on and off. So in this case, I could say I want to save all of the things, but I don't want to actually save this map. I can save selected. It'll save all of those. And now we still have this one unsaved, which is our actual map out here. Now then, if I were to go ahead and save this map, then it'll tell us all saved, and we'll see all saved down here. And then that's all we have to do. We can now go on with the rest of our project.
All right, so we've talked about building scenes with content, and I've shown you what it looks like a couple of times to just drop in and play in the editor. But let's take a moment to get familiar with using this feature. Now, assuming you created your project with the third-person starter template, you should be all set up with a default game mode that will let you play. Here in the template level, when you first open Unreal, you can go up here and click on this green play button to drop in and play in editor. The hotkey for that is Alt-P, and then Escape to exit. Once you hit play, take note of this message that says, click for mouse control. This means that to start playing, you need to click once in the viewport to go into game mode. You can then hit Shift F1 to get your mouse cursor back. The messages in the upper left should remind you of this if you forget. Once you're playing, it's standard PC gaming controls. WASD to move, just like getting around the viewport in edit mode, and then spacebar to jump. Next, let's talk about eject and possess. When you're playing in editor, you could say run your character up here, hit Shift F1 to get your mouse cursor back, then go up here and click on this eject button. This will eject you from the player so you can move around the scene just like in edit mode. Except the game world is still playing. Click the gamepad icon that it changed to in order to possess the character again. This can be really useful if you need to do something like, say, test out moving an object in the scene. Just eject, move the object, and then possess again. Note that when you exit play mode, this change will not be saved, so you'll need to repeat the action for real outside of play mode. Notice that when we hit play, we always start from the same position. This is controlled by an actor called Player Start, which looks like a flag with a gamepad icon. Wherever you place this actor in your scene is where you will start whenever you hit play. You can, however, go up here to the 3 dots menu and change your player start at location to current camera location. This will make it so that when you hit play, you'll drop in wherever you happen to currently be in the viewport. Being able to drop in and play is useful, but sometimes you just need to see some action that only works when the game is in play mode, but you don't need to actually run around with your character. You can do this with the Simulate functionality. Going to the 3 dots again, you can see a list of options under Modes. Selected Viewport is what we have been using, and it's the one that you'll be using most of the time. Many of the others are special cases. The bottom option of Simulate, though, can be very useful. It'll let you activate the game world without actually playing in it. Let's unpack a use case. Bring up the content browser and go to Starter Content Particles folder. Find the P_explosion and drop it into your scene. Notice how when we dropped it in, it exploded once, but never again. This is because it is a one-time event, as you would expect an explosion to be, or at least you would hope it would be a one-time event, or maybe a no-time event. Now let's go up to the 3 dots and change our mode to Simulate. Notice how when you change it, it immediately drops you in. If you hit Escape, you'll see the play icon has changed to let you know that you are set to Simulate mode. Now you can hit play to simulate all you want. Very useful for tweaking positions of one-time events like explosions. Alright, so you've done some cool stuff in Unreal and want to show it off with some screenshots. There's actually a really quick way to get these screenshots as long as you know how to grab them and where to find them once you do. Let's jump right in. Here in the editor, grabbing a screenshot is quick and easy. First, hit F11 to maximize the viewport. This is a toggle, so you'll hit F11 to go back again. You can also use Shift and F11 to toggle full screen, hiding your taskbar. I recommend doing this because it'll give you the correct aspect ratio if you're on a standard 16:9 screen. Hit the G key to go into Game View, which hides all your widgets. With your full screen viewport, now just hit F9 to take a screenshot. You'll see a little pop-up message that you can click on to go directly to your screenshots folder. But if you miss it, don't worry. Just go to your project folder in Explorer or Finder, go into the saved folder, and then you'll see a screenshots folder. This is where all of your screenshots are saved. Now, what if you have a view that you want to continuously capture as you iterate? Well, the best way to do that is with cameras, which we'll go over in depth in the full course. But right now, I want to introduce you to a little trick to save viewport camera locations. These are called bookmarks. To create a bookmark, you find the view that you want, then you hit Control plus a number to save it. To demonstrate, I'm going to hit Control plus 1 to save a bookmark here in my scene. Then I'll go over here and hit Control plus 2 to save another bookmark. I can now use 1 and 2 on my keyboard to quickly jump to each one of these camera angles. Now, if you go up to this hamburger menu in the upper left of the viewport, you'll see an item called Bookmarks. This is where you can go to see and manage what bookmarks you currently have saved, as well as you can set bookmarks here too. I highly recommend using the hotkeys though. All right, now you know how to grab screenshots so you could be able to show off your work. Later in the full course, we'll go over cinematic camera settings so you can get the real good shots. For now, take everything you've learned so far, play around to get comfortable working in Unreal, and take some screenshots to share what you're working on. In the next module, we'll start diving into working with assets so we can start creating even cooler scenes for you to take screenshots of. All right, let's look at how we can get our hands on some really cool free 3D assets that we can use inside of Unreal Engine using a service called Quixel Megascans. Let's jump right in. All right, so what we're going to do is we're going to go up here to our Quick Add button. We're going to come down to this Quixel Bridge, and when we click on it, it's going to give us the Quixel Bridge browser here. So I'll go ahead and maximize this. Now, before we can actually use anything in here, we do need to sign in. So you can come up here to the little My Account button. We'll click on that, click Sign In. And then just like with the launcher, you're going to sign in with your Epic Games account. Now, it's really important here that you sign in with your Epic Games account. This is going to allow you to use all of the Megascans assets for free, as long as they're used in Unreal Engine. Any of these other options that you see through here, these are all going to come with a monthly fee. So just make sure that you're signing in with your Epic Games account. All right, now that we're signed in, we're greeted with some options for some collections of assets that might fit within a certain theme. Right now I'm looking at Arctic ice and snow, contemporary surfaces, some of these other ones. And then if we scroll down, we can see some of the recently added assets. In here in Megascans, you're going to see your materials, you're going to see 3D models, plants, all sorts of things in here. In this lesson, we're going to focus on 3D models and materials. So first, let's look at models. We can go over here to the side menu, and we're going to click on 3D assets. When we do that, it expands down and you can see all kinds of categories that you can drill down into. For now, we're going to go to props. Now, if I click on this, we have even more categories that we can go into. So just to start out with, we can pick one that we like. I'll go for, how about farm? We'll click on this. And then we come in here and we see all kinds of these 3D assets available to us. So let's go ahead and click on one of these. I'll click this keg here. Now, when we do this, it's going to pop up over on the right with the information for this. Now, a few things that I want to point out. Right off the bat, we look over here and we see size. We can see a little icon of a person and then a shape. The shape actually represents the asset itself. So this is in relation to the size of the character. So everything in this category seems to be pretty small. If I were to say, go up here to nature, and then we'll go into, how about rock? And if I were to click on this beach cliff, now you'll see that the person is smaller and the shape is bigger. So that's the asset in relation to the actual person size itself. Now next to it, you'll see this partial circle that says open. That means that it is an open 3D model, meaning that there are sides of it that are not complete. So in the case of this one, it's probably the back of it's not going to have anything in it. And if we go back to props again, go back over to farm, I'm going to grab my keg here. You'll see this one says closed. That means that it's an entirely closed 3D asset. So right now, we'll do this one. And if we come down here, we can see this drop down that has a quality on it. We have a low quality, medium quality, and high quality. Now, these are mostly going to pertain to the size of the textures for low quality and medium quality. And then high quality is going to be your much larger, a lot of times larger poly counts. You're going to have larger textures. And then you have a nanite option as well. We'll get into that much later. But for now, for this guy, I'm just going to leave it on medium quality because that's going to be something that we can work with fairly easily. So next, what we want to do is we want to come over here to this download button. And if we click on that, what it's going to do is it's going to actually download this asset to our library. Now, this doesn't actually put it into the project. It just makes it easily available within our library. And then when the download finishes,
you'll get this add button here. Now this add button is going to actually add it to the project. So let me minimize this a little bit. I'm going to bring up the content drawer here. I'm going to dock it. Let's close all of that and go into our base content folder. Now, if I actually click on this add button now, what it's going to do is add it to the project. Now we see that we're in this new folder. We see the static mesh here. We see a material, and we see some textures that are associated with it. Also, if we go back to our content here, we'll see we now have this Megascans folder, and we have this MS presets folder. Now, MS presets is going to be a folder that Megascans is going to use to store all of its default master materials and things like that. The actual Megascans folder is where we'll find the assets. So we come into here, we see 3D assets, go into this, wooden keg with some gibberish on here. That's the ID that's appended to it. Go in this, and now we have this guy. If I move this out of the way for now, I can take this and I can drag it into the scene. We'll focus on it, and now we can see this beautiful 3D asset right here in the scene. And what we can do is we can download and add a bunch of these and use them to construct some beautiful scenes, no matter what it's for. This gets used a lot in the game industry, gets used a lot in film, virtual production, all of that. Now, the other side that I want to look at here is the materials. So what I'm going to do is come up here to Quick Add. We're going to come down to shapes. I'm going to drag out this cube. We'll bring it up like this. Now, we already know that we can go into our starter content, materials, and we have all kinds of things we can do and, drag this material on here to get this little brick wall. But Megascans actually offers us a lot of really cool materials. So let's come back into here. This time, I'm going to close 3D assets and come into surfaces. Now, surfaces is a term that gets used across a couple of different CG industries that means materials. So when we click on it, you can see all kinds of stuff in here. You can see categories again that you can go into. Let's go to this historical category, and I'm going to grab this brick right here. Mossy stone floor, but it looks close enough to a brick wall. And then we're going to download this with the medium quality. Let that do its thing. And while this is downloading, another thing that I want to point out that makes materials different from the 3D assets is that if we look up here, we no longer have the person and the shape to designate size. What we have instead is this square with the size of the textile density on this. Now, what this says is 2 by 2 m for meters, which basically means that this particular material is meant to cover a 2 by 2 meter surface. So to get this correct, while that's still downloading, I'll move this out of the way, and I want to look at this guy right here, and we want to figure out how big this cube actually is. Well, quick way to do that right here is knowing that we can come up here to our snapping tools. Right now it's set to 10. I'm going to change this to 100, which is going to change the size of our grid pattern that you see here. And so now each one of these squares is equal to 100 centimeters, which 100 centimeters is equal to a meter. So what that means is that to get a 2 by 2 meter cube here, we're going to want to come in and double the size of this, because currently it is a 1 meter cube. To do that, we will hit this padlock button on scale, and then we're just going to set this to 2. Now we have a 2 by 2 meter cube. So I'll move this over here like this. We're going to bring you up like that, move you over here, maybe move you that side. There we go. That works for me. So let's come in here. And we're going to, since it's finished downloading, hit add. And then when it does that, we'll now see that we have this folder. Just going to go ahead and drag this out on here. There we go. Now that size is not looking right to me. Now, why is that? It feels a little big, but just to double check, we don't necessarily want to rely on our eyeballs or even rely on this little guy right here, to figure that out. So what we're going to do is we're going to get some scale reference. And just like we mentioned before, we can do that with the character that we started the third person template with. So to get that, let's come down here to the content. Wait, we want to go into character, and then we're going to go into mannequins and meshes. And then I'm just going to drag Manny out into the scene. Now, if we look at this, Manny here, and if we were to bring out Quinn as well, these are actual character sizes. These are real world character sizes. And now if we look at this, suddenly it doesn't look as off as it did before because this guy is really, really small. You might be thinking, well, hey, that keg is probably closer to, like a size like that. So you always want to make use of your characters here to be able to use the scale references. Now, this right here, for what it is, it's supposed to be floor tiles. So if I bring Manny up on top of this, okay, well, that makes sense. Yeah, that's about right. 2 by 2 meters for these floor tiles. Well, what if we were to grab some bricks? Let's see, temple stone tiles, 2 by 2 meters. We can see that there's definitely more of them than there is in this one. So we'll go ahead and hit download on these. All right, now that is finished, we can hit add, move this out of the way, and we can see if we go into content and back into Megascans, we'll notice that in addition to our 3D assets folder, we have a surfaces folder. It's where all of our materials are. Let's grab this temple stone tiles, and I'll drag this out on here. And now that looks a little bit more accurate for what I would expect from some bricks. Now, one other thing that I do want to mention is that whenever we're dealing with all of these Megascans assets here, especially with the surfaces, we want to make sure that we're actually dragging the materials onto these assets and not the textures themselves. So we'll get into how we work with these textures a little bit later, but right now, just remember you want to go in here and drag in the materials to drop on these. All right, so now you know about this really cool free 3D asset library that you can use with Quixel Megascans. That's going to help you get some really good practice in with doing some scene layout using some really high quality assets. All right, so in October of 2024, Epic Games released the FAB Marketplace in an effort to replace the Quixel Megascans library and the Quixel Bridge app, along with things like the Unreal Engine Marketplace and all of that. And of course, this really, really complicated things for us Unreal Engine users. And now, while we can still use the old method with the Quixel Bridge app, at least for the time being, where we use Quixel Bridge inside of Unreal to add all of our assets to our project, just like we've been doing. There is a new way to do it now that we have FAB. Now, of course, we are going to need to go in and add the FAB plugin to our Unreal Engine installs, and then we will be able to start using the plugin inside of Unreal. So let's go ahead and take a look at how we're going to do that. First thing, let's have a look at the new marketplace. So we come here to fab.com, and you'll see if you go up here to My Library, we'll now find everything that we purchased from the Unreal Engine Marketplace, as well as our Quixel Megascans assets that we've actually added to our library. Now, the big question and the big problem a lot of people have with this is how do you actually find the Quixel assets now? Well, what we have to do is we're going to come over here to Discover, and then I'm going to come up here to the search bar, and I'm going to type in Quixel. Now, right off the bat, it gives us some stuff that we'll see showing up here. It's not really categorized very well. Some of it is Quixel, but also some of it is not. This is going to find anything that has Quixel in the name, the description, the tag, anything like that. So this might not all be Quixel stuff. Another thing that we can do, though, is when we search Quixel, we can come here to creators, and then we'll see up here Quixel as an actual creator. So we'll click on this and then we can come in here and we can see all of the assets that Quixel has in here. And from this point, we can start to come to click on things like materials and textures, for example. Now we can see all of these materials that we have in here. Now, of course, if we were to say, click on one of these like this desert outback ground, we're going to see some things in here. We're going to see you own this item if you've done your claim all, where you're able to claim all your Megascans, the entire library for free, as long as you do it before the end of 2024. But you'll see download and you'll see add to my library. Now you actually have to click on the add to my library for it to show up in your library. So now when I come up here to my library, I can see here is my Quixel asset that I've added to my library. And even though I have claimed and own the entire Quixel Megascans library, it doesn't show up in here. It's only going to show up when you come in here and you click to add it to my library. So now I look at this, and if I were to click on download, we'll see all kinds of options in here. And none of this is actually useful for when you're trying to use it inside of Unreal. It's great if you want to download the raw textures and use them that way. This makes it more difficult to use in Unreal because you would have to actually drag and drop import these. So the better way to do that inside of Unreal is to do it with the FAB plugin, which is out now. But how do we get that? Well, you actually have to install the plugin. So to do that, to install this plugin, we need to go to the Epic Games launcher. Now over here, if you go to the FAB tab, you're going to see basically just a button that says start exploring. This is just going to link us out to fab.com website. What we need to do is we need to come to library over here, and we need to make our way down to our vault section, which they are now calling the FAB library. Now, this year, we need to make sure that filter by category, we're going to leave it to all. You click in here, things are going to go off. We're just going to click the all button, make sure we can see everything. Come to the search bar here, and you type in FAB. And what you'll see is this FAB UE plugin. Now, this right here, we can see that it can be installed for 5.3, 5.4, and 5.5. So if you're using 5.2 or earlier, you're going to have to use Quixel Bridge. So that right there tells me that Quixel Bridge is still going to stick around for a while. So you will still be able to use it, assuming that you have already claimed and added things to your library. But for the new method with FAB, we're going to need to click on this install to engine, and I already have it installed to my 5.4, so I'm going to go ahead and install it to the 5.3 now. So we'll do that. We'll click install. We'll let that happen. And now once that's done, I can go ahead and open up my Unreal Engine project. Then once it's open with the plugin installed, we can come up here to Window, and we're going to come down and we're going to find FAB right here. We click on this to open it up, and then we're going to see the FAB Marketplace UI right here. And right in our face, it's going to show us a bunch of stuff that it wants us to buy, or it's going to show us some stuff that it wants us to add for free. But if we come over here to the hamburger menu on the left, this is where we're going to find our sections. So we have a Discover section, and then we have a My Library section where we can find all the things that we've added to our FAB library, which anything you've gotten from the marketplace is immediately going to show up here. You can see this Quixel material that we added earlier from the website is right here. So I click on this, and what I can do now is I can come over here. We're going to come to my content browser. I'm going to go to settings, come down here and change my thumbnail size to small so I can see things here a little bit better. We can see in this project, I have my old Megascan stuff with my surfaces here and my MS presets, which have the master materials for the old Megascans. But in here, if I were to add this to project, it's going to bring it in here, and it's going to add it to a new folder. So I go back up to content, and we had our Megascans folder with our old stuff. The new folder is going to be called FAB. Then inside of that, you're going to find Megascans. And then inside of this, here's my surfaces, here's my desert outback, medium was the quality, and I can see this material instance right here that has all of this stuff in here. And one thing that you'll note that has changed from the old Quixel Megascans way of doing things is their mask textures are now the industry standard ORM, ambient occlusion in the red channel, roughness in the green, metalness in the blue. The old ones used to have displacement in the blue channel, which also put you in a situation where a lot of your Megascans materials did not actually have a metalness value to them, so they weren't really true Unreal PBR. Now, if I wanted to get an actual 3D asset here, we move that out of the way. We're going to click this little back button in our plugin here. Here I am in my library. I've got some things that I have added here. Let's go ahead and X out of the My Library for the search results. results here. I'm going to type in Quixel up here to the search bar. We're going to come down here to creators, just like we did on the website. And then from here, I'll go to Quixel. And on this, we're going to have a bunch of stuff in here. So I'm going to go ahead and then click on 3D models, which is going to filter down to the 3D models. And we're going to have some categories here. So let's say we'll go into nature and plants, and then we can dial down into, we'll say, trees right here. And now we can see these full trees. I'm going to go ahead and grab this Nordic forest tree trunk right here. I'm going to click on it, and then we're going to have some options in here. We can see once again, you own this item because I did claim them all from the easy way to claim all of these assets for free with just a couple of button clicks. There's another video for that, but on this, I'll leave it at medium quality here. I'll go ahead and click add to project. We'll see that it downloads. It imports. Once again, it puts it in the FAB Megascans folder, but now we have 3D in addition to surfaces. So here in 3D, in this, I have my quality level. So what I can now do is drag this out into the map. And now here we are, we have this tree stump with the new setup pulled in from the FAB plugin using the new ORM textures, and we should be good to go from here. And there we go. There you have it. That's how we can start using the FAB plugin in place of the Quixel Bridge plugin to get these Quixel assets inside of Unreal.
All right, so we've dealt with materials just a little bit already. We've used the materials in the starter content, and we've even added some materials from Megascans. We know what it's like to drag and drop a material onto an asset, but in this video, we want to dive in just a little bit deeper and start to get familiar with the material editor. Now, the material editor gives us a graph to work in where we connect together nodes to perform shader calculations, and then ultimately output those into a collection of parameters which are then compiled down to a material. The interface consists of three main areas that we'll be paying attention to. The main graph area is where all of the magic happens, the details panel, where we edit settings for individual nodes, and the viewport, where we see the result of the compiled material. Let's dive in and create a material of our own. All right, to get started, we're going to go up here and we're going to create a new basic level to work in. I'm going to go ahead and save this. I'm going to put it in the maps folder in my stuff. I'm going to call this material demo. Next up, we're going to want a mesh to demo our material on. So we're going to use a material sphere. We can come up here to the quick add down to shapes, and we can add a sphere into our scene like this. Next, let's go down into our My Stuff folder, where I'm going to create a new folder by right-clicking and going up to New Folder. I'm going to call this Materials. We'll go into this folder, and then I'm going to right-click, and I'm going to go up here to the Material option under Create Basic Asset. When I click on this, it's going to create a material down here with the default name of New Material. I'm going to rename this to M for Material _ my first material, just like that. Next, we're going to take this and we're just going to drag and drop it onto this sphere right here. Now, what you'll notice is that right off the bat, this particular material has this gray checkerboard pattern. And that's basically the default inside of Unreal. So this means that this material is not actually doing anything. So Unreal is defaulting to this checkerboard material. So let's go ahead and get in and customize this material. I'm going to come down here and double click on this to open the material editor. I'll go ahead and expand it. Now in here, we have our viewport, we have our details panel, and we have our graph, just like we just looked at. Now our graph is where we're going to be doing all the work. So to get around in here, we're going to right click, and then we can drag this around to move wherever we need to. And we can use the scroll wheel to zoom. Now for these materials, we'll need to create nodes that we plug into our output here. Now, there are a lot of nodes that are available to the material editor, and you can find all of them by right-clicking, where you'll find all of these different categories available. Now, there's a lot of stuff in here. So this dropdown is really useful if you know what category you need to be looking in. But if you know exactly what you're looking for, you can use the search bar up here. So let's say we want to create a basic color node. Well, if you were to type in color, you're going to get some options in here that aren't exactly what you're looking for.
There's some things that you're going to need to remember when working with these materials here. So to get a color, we need to use what's called a vector 3. Now, if I were to come up here and type in vector and vector 3, that's not finding what I'm looking for. And that's because the name that Unreal Engine uses for this particular variable type is actually constant 3 vector. So it can get a little confusing with some of those names. That's why it's really good to get familiarized with some of the hotkeys inside of the material editor. So if I were to click on this, I'll get my constant 3 vector here. But another way to grab one of these guys is if you come out here and you hold down 3 on your keyboard and then left click, it'll create one like that. I can drag over and select this and hit my delete key to get rid of that one. Now, if I wanted to create a scalar or a constant 1, which is a 0 to 1 grayscale value, I can also hold down 1 and click to get that. So what's the difference between these two nodes? And more importantly, how are they actually similar? Well, the vector 3 up here is actually 3 of these. So if we have 3 of these like this, each one of these pertains to a color channel. So red, green, and blue, RGB. And you can see that up here on the node. You can see the outputs for R, G, and B. And then you also see this 4th one up here. Now, these 3 outputs are the individual channels of red, green, and blue. This top one that's white is the combination of them. So if you're looking for an actual color, then you're going to drag out from this. So what we're going to do now is we're just going to left click on this guy, and I'm going to drag this out, and it's going to give me this chord. I'm going to plug it in to the base color here. Now to actually change the color, we can double click on this swatch right here, and it's going to bring up a color wheel. So if you're familiar with Photoshop, it's very much like working within that. So if I were to drag this over here to get kind of a purplish color, you'll notice that over here it doesn't change, and that's because our value is still at the very bottom here. It's black. So if I were to start to bring this up, we can see how it starts to capture this purple color over here. So you can see a combination of all of these things. So you've got your color wheel here, where you can manipulate the color visually. Down here, you've also got the actual red, green, and blue values. And then over here, we have our hue, saturation, and value. For now, let's commit to this purple color here. So I'm going to go ahead and click OK. And now, if I were to drag this down, we'll see that we see it in our viewport here in the material editor, but we don't actually see it on our sphere that's in the world. And that's because we have to actually compile this material before it shows up in the world. To do that, we need to come up to our toolbar here, and we're going to click on this Apply button. When we do that, it compiles the material, and now we see it in the world. But if we were to come back in here and, say, change this to more of an orange color, I click OK. Once again, you'll see that the change is not updated in the world, so we have to click Apply. But what if we wanted to see this real time? Well, there's actually a really easy way to do that. We're going to come in here to our node. I'm going to right-click this node and just select this Convert to Parameter. When we do that, it's going to have us name it. I'm just going to call this Color, like that. We'll hit Apply again. And then now, because it's a parameter, if I come in here and I start changing this, we'll actually see it real time in the world. Now, parameters are something that we'll go into in detail once we start covering master materials and material instances. But just know that if you ever need to be able to access the changing of one of these values real time, you'll have to convert it to a parameter. All right, I'm going to go back up here and maximize this again. And another thing that I wanted to go over is these channels. So we can see the R, G, and B channel here. So if I were to drag the red channel over here and plug it in, it's going to turn our material preview over here more of a whitish color. Now, why is that? You would probably expect that to be a red color, or you would expect this to be a green color, or you would expect this one to be a blue color. But the reason for that is because these are the individual channels. If you double click on this again and you see your channels down here, you'll see these broken down into their individual channel values. And that's why this red is a little bit brighter here. The green is a darker gray and the blue is actually black. Now, you'll notice when we converted it to a parameter, we now have this fourth channel right here. This is our alpha channel. So that is going to store another set of data that we don't have available with just this typical RGB. And we'll go over that much later in detail. All right, so now we have something here. Let's plug this back in. So we have our orange color. And we're going to look at some of these other options in here. Namely, the primary one I want to point out is roughness. So roughness is part of the physically based rendering pipeline, or PBR, which we have a whole video covering that coming up. But what you should know about roughness is that your 0 is going to be a glossy and your 1 is going to be more of a matte. So if I were to drag this out and plug it in here, you'll see how glossy this becomes. Now, if I were to set this value to 1, now it becomes matte. If we were to set this to 0.5, it's going to be right in the middle. And this is actually the default value if you were not to plug anything in. So if we were to do the same thing as with color and right-click this and convert it to a parameter, I'll call this roughness, and then we'll hit apply. Now we can actually change this roughness real time by coming over here and sliding these values to get matte or glossier. Now, something to be aware of is that roughness is one of those values that you only want to exist within the 0 to 1. Anything below 0 or over 1 is going to give you some artifacting that you definitely don't want. So something we can do here when we've converted this to a parameter is if we look in the details panel, we can see that we have a slider min and a slider max. 0 and 1 are what we want to put it to. But sliding it through here, we can still see that it doesn't reflect that. Then after we hit apply, we now have this clamped here, so we can't go below 0 and we can't go over 1. I can also click in here and I'm just going to type 0.5 to set that to middle of the ground. All right, the next one that I want to look at is the metallic value. Now, metallic in PBR typically only comes with two possible values. It either is metallic or it's not metallic. Now, there are instances where you will have a value in between 0 and 1, usually pertaining to things like rust, or if you're trying to do something like a silk or a satin. But generally, your material is either metal or it's not metal. By default, the value here is 0. So if I were to plug this in with a value of 0, nothing's going to change. Because by default, Unreal assumes that a material is not metallic. But if we were to change this value to 1, now you can see that we have a metallic sphere here. So if I minimize this down and I hit apply, now we can see this metallic sphere out in the world. All right, now if I were to come in here and start playing with our roughness value, we can see that we can get a really shiny metallic surface, almost mirror-like, all the way up to a very matte surface, and then everything in between. So we could say, come in here and I'm going to go about like this. There we go. And then we're going to take the roughness down a little bit more. And then suddenly we have this nice gold material right here. So I'll hit apply to commit to that. And there we go. Now we have our first basic material. All right, that's the basic intro to the material editor. Up next, we'll look at bringing textures into this. All right, so in part 1, we got a brief introduction to the material editor and working with our first two nodes. Now we can create some basic materials with just these mathematical nodes, but to really take advantage of this material editor, we need to start to introduce textures. All right, let's start to enhance this material with some textures. I'm going to go ahead and drag out a duplicate of my sphere here so we can compare them. Going to come down here into the content browser, click on my material, and then Control D to duplicate it. Now, if you happen to be doing this in Unreal Engine 4, then that's actually Control W, not Control D. But in Unreal Engine 5, it is Control D. All right, now I'm going to drop this on here and going to go ahead and name this M underscore my second material, just like that. And you can see that we can rename it after we've applied it. All right, now let's come down here and we're going to double click to open this guy up. I'll go ahead and close my first one so I don't get confused. Now what I want to do is I want to bring a texture into this. So for that, let's go ahead and go to Content, Starter Content, and I'm going to go into the textures. Now there's all kinds of stuff in here. What I'm looking for is a particular kind of noise. So I'll just go up here to the search bar. I'm going to type in noise. I can see this Perlin noise right here. That's going to work for me. So I will drag this in here. And now I have a texture in my material editor. So right off the bat, let's go ahead and get rid of this guy. Now, if you remember, for our roughness, this is a single channel value. It is a grayscale value. So when we're using a texture like this that we want to plug into one of these single values here, we would want to use a particular channel. Now, what do these channels actually look like in this texture? Let's go ahead and double click it over here. And this is going to open up the texture viewer. Now in the texture viewer, we can single out these individual channels. This particular one happens to be a grayscale, so all of the channels are the same, but if you were to say, for example, come down here and let's open up this lamp. All right, now if I expand this, if I were to close off the blue and the green channels, we can see just the red channel, we can see just the green channel, and we can see just the blue channel here, just like that. Now, in these individual channels, white is full, black is none. And with this one, you can see the checkerboard pattern behind it. That means that it does, in fact, have an alpha. So if I were to turn that off, now we can see that throughout this whole thing, there's a bunch of red. So if I were to turn off green and blue, there's all that white there. But if I turn on just green, we'll see that that becomes black. But for now, let's go ahead and close this out. We're going to work with this. And what I'm going to do is I'm going to plug this green channel into our roughness here, just like that. And now we can see if we look in the viewport here, we have these differing roughness values. So we have some that are really glossy and some that are not so glossy. Now, if you remember what we looked at last time, 0 is glossy. So in this case, black is glossy, and 1 or white is matte. So with these grayscale values, we get a whole range in between with that. And of course, to demonstrate the difference between metallic and non-metallic, if I just come over here and I change this metallic value to 0, now it looks a lot different. We still have the black areas, which are catching some light and reflecting quite a bit. And we have the matte areas that are not reflecting as much. So if I were to hit apply on this, and then we come down here and we look out in the world, we can see how the sun is reflecting off of this. And if I were to come up to my directional light, I'm going to turn off effects world real fast, then just come in here and add a point light. I start moving this point light around. Let's turn off snapping. And I will turn this down a little bit. There we go. We can use this point light to see how some of that roughness is affected. Now, when the light's shining directly on it here, it gets really blown out, even in the matte areas. But in some of the more diffused areas, that is where we can really see where this roughness variation picks up. All right, now I'm going to delete my point light, go back to my directional light, turns effects world back on. There we go. And the next thing that I want to do, I'm going to bring my material editor back up here. And this time I want to plug in a texture to the base color. So I'm just going to go down through here and I want to find one. We're going to type in grime. Here we go. I want to get this concrete grime here. I'll just drag this in like that. And then if I were to plug this in to base color like that, there we go. We have this color on here coming from this texture. And we also have this roughness from this Perlin noise variation down here. So you can see how those being different, how they interact and create some very interesting variation. Now, if we wanted to give some depth value to this material, we would do that with the normal here. So let's go down here and I am going to look at these. We'll see these normal maps. There are these kind of bluish, purplish color ones. And I can filter on those by going into search and typing _in. We can come down through these, and I think I want, we have this nice ground gravel here. If I were to drag this guy in like that, and then what I'm going to do now is drag this over here and then plug this RGB into normal. And then now we have some nice little bumpiness to this that you can see. So with this, we can go ahead and we can hit apply, bring this down, move it over to my other screen. Now we can see on our material ball here, we've got this concrete grime color going on. We have some roughness variation, and we have some normal map detail to give it some bumpy depth. Now, of course, most texture-based materials are built with all of these channels in mind. An example that you can actually see with these Megascan assets. All right, to do this, what we're going to do is we are going to right-click and go to Material again to start fresh, M_ my third material, just like that. And then I will double-click this to open it up. Then we're going to come and actually download a Megascans asset. So we'll go up to Quick Add, down to Quixel Bridge. And for this, we're going to go into Surfaces. And let's find something good here. I think I'm going to go into Historical. And I really like this Fort Stone Wall right here. But for this, let's go ahead and we're going to download this and add it to our project. Then I'll click Add, and then we'll minimize this. Can actually close that out. And we'll come down here to find our Megascans folder, Surfaces. Here's our Fort Stone Wall. Now, of course, Megascans does create a material for you using its master material presets, but we want to look at how this all fits together. So we're going to create our own here. So right off the bat, we're going to drag this D in here, where the D stands for diffuse, which is also synonymous with the base color. So I can plug this RGB in to the base color by dragging off and plugging it in, just like that. I'll go ahead and drag the normal in and this ORDP. And then I can drag the RGB from the normal, plug it into there. Then we'll hit apply. And this is not that easy to see on a sphere, so I can always go down here and change this to a different shape, maybe this cube right there. There we go. That's really good for when you're trying to look at materials that are going to go on something like a wall. But with this, now we can see the color on there. We can see the normal map detail, but it looks really weird, kind of, super glossy and wet. Maybe not what we're going for. But that's what we were talking about with these materials that are made where all of their textures are made together with the final result in mind. They will have their roughness and metallic values and stuff like that in there. So with this, we actually have it in this ORDP. Now, the ORDP, if I were to double click this to look at the image here, these individual channels stand for a different parameter in there. So if we just single out the red channel is the O, which stands for occlusion, the ambient occlusion. The green channel is the R, which stands for roughness. This is what's going to control our glossiness in there. And then with the Megascans assets, the B channel is DP, which stands for displacement. Now, we're not going to use that in this material here. We'll get into that much later. But this is basically a height map that allows you to displace a mesh. For now, our main thing that we want to look at is the green channel, which is the roughness. So if I come back over here, I can drag that G out and plug it into roughness. And now this looks correct over here. Now the O, which stands for ambient occlusion, we do actually have an ambient occlusion output node here. So let's go ahead and drag that red and plug it in there. Now you're not going to see much happening in the actual material itself. Basically what this ambient occlusion here does is it controls the self-shadowing in the lighting. So this is not something that you see directly in the material itself, but rather this is something that the lighting environment reads from to add in that little bit of extra depth. Now, if you did, for some reason, want to enhance the ambient occlusion in the actual material itself, you can do that. Now, if we come back over here, let's look at this again. We can see this red channel. Basically, the darker areas are where you can see the shadowing. So if we wanted to add that to our base color, we could actually do that with a node called multiply. So if I were to right click in here and type in multiply, we'll see multiply here that we can click on to add as a node. Also, the hotkey for that is if you hold down M and click, you'll get a multiply node. So let's go ahead and delete this one. And what I'm going to do is I'm going to feed this base color into here, and then I am going to multiply it by the ambient occlusion like that, and then drag this multiply here to plug into the base color. Now, as you can see, we have some of that shadowing actually in the material itself. So if you ever need to get a really, really pronounced deep ambient occlusion shadow, then you can do it by multiplying your ambient occlusion onto your base color. So if I hit apply on here, and then we'll take this down, what I will do is go back into my stuff, materials. There's the third material. Going to go up here and I'm going to actually add a cube this time, just like that. And we'll drag this onto there. Now we can see this out in the world, how the different lighting affects it. And that is how all of these textures work together to create a material. All right, we have barely scratched the surface on what you can do with materials inside of Unreal Engine, but you should be a little bit more familiar with the material editor. Shader development with the material editor in Unreal is one of the most powerful features this engine has, and we'll be covering an almost endless set of topics and recipes on this in the full course. Now that you're a little more familiar with the materials, you'll be well equipped for the next chapter where we're going to be importing custom assets. I'll see you there. All right, so we've explored using 3D assets inside of the engine, and even how to obtain some really high-quality assets with Quixel Megascans. Layout artist is a very popular job in the industry right now, but 3D assets can come from anywhere. Creating 3D assets is a job in and of itself. In the modeling, texturing, and rendering triangle, Unreal acts as the renderer. Now, if you're a 3D artist like me, then you've probably been wanting to get your own work into the engine. Maybe you have a friend or a colleague who's a 3D artist, or maybe you've downloaded a model from an online marketplace. Either way, getting art assets into Unreal is actually pretty easy. Let's have a look. All right, if you've downloaded the file for the Jenny Lin trunk and unzipped it, you should see two folders inside of that. There's going to be model, which is going to have the actual models themselves, and a textures folder, which has the textures for it. Now, I'm going to pop this back over to the side here on my other monitor, and what we're going to do inside of Unreal is here under my stuff, going to create a new folder, and I'm just going to call this import demo, then go inside of this folder. Now, in this folder, there are a couple of different ways that we can import. We can actually right-click in here and go up to import, and this is going to give us a browser to navigate to our folder where we unzipped everything. We could also go over here to this import button, which is going to give us the same thing. But I find that the easiest way to import something into Unreal is actually to just drag and drop it. So if I bring my Explorer window over here, or if you're on a Mac, you would bring your Finder window over. And I'm just going to go into this models folder and then drag and drop this right here like that. Now I'll move this back onto the side. And this is our FBX import options here. Now an FBX file is a type of 3D model. Technically, what the FBX file format is, it is a container file that can contain models, it can contain materials, textures, animations, all sorts of things in it that it can contain. But for this matter here, this particular FBX file, the trunks FBX, contains 2 models inside of it. Now, what this is going to do is it's going to import both of those models to Unreal. It's going to be just like in our starter content or anything that we downloaded from Megascans, but these are custom models. So with that in mind, let's look at our FBX import options here. Now there are a few things that we need to be aware of. Right off the bat, up at the top, we see this mesh category. There's an option for skeletal mesh. Now, this is going to pertain to a rigged mesh, so like a character or anything that has a rigged skeleton to it. In this case, we're importing a prop, so it is not a rigged mesh. It does not have a skeleton, so this is going to be unchecked. Now, what's really cool is most of the time, you don't have to pay much attention to this right here because Unreal will automatically detect if your model has a skeleton or not, and will automatically check this if it is a skeletal mesh. But for this here, we don't need it checked. Next up, we'll see this build nanite. Now, nanite is a new function inside of Unreal. We have a whole video that goes over what that is, when to use it, when not to use it, why to use it, all of that. Now, if you're used to working on Unreal Engine 4, then you might be familiar with the LOD system, the level of detail, or maybe you've heard that from another game engine. Nanite is Unreal Engine 5's new version of level of detail. So we do actually want to build this even if we don't plan on using it, because if we want to change something over to use it later, if we didn't originally import it with this build nanite turn on, it is a little bit cumbersome to re-import it and have it rebuilt. So let's go ahead and turn this on right here. This right here, generate missing collision. This basically means that Unreal is going to automatically create collision for your meshes. Now, if you're working in film-related stuff, this is not going to matter too much for you. If you're working in game, then this is going to be a magic bullet for you, unless it's a super complex object where you need to build custom collision. Either way, if you don't need it, it's better to turn it off later. So we'll go ahead and leave this turned on. A lot of the other options in here you can leave at your default. One important thing I want to point out is the import uniform scale. This right here, we do want to leave it at 1. And if something just seems messed up when you import it, it's not the right size, then it is best to identify that on the export side rather than the import side. So say, for example, you modeled something in the units of meters instead of having your modeling package set to centimeters. It might be tempting to come in here and set this value to 0.1. You want to avoid doing that. That, especially if you're in a production environment, you want to identify those scaling issues on the modeling side before they get to Unreal. All right, next up, we'll leave these guys as default. And then down here in material, it has the capability of creating a new material for your mesh based on what is in there and then setting that up and importing textures and all of that. And now working in production in both the game industry and the film industry, I have found that 99 times out of 100, this is not going to do what you want it to. And especially if you are working within a pipeline that already exists, then you're probably dealing with master materials and stuff like that. So really, you want to turn this off. So what I do here is material import method. we'll just click on this and we're going to go down to do not create materials. And then also I'm going to turn off import textures because we're going to do that manually, especially considering that most of the time your actual PBR textures are not going to be tied to your models in your FBX. So we're going to be importing those separately. Now, once you change all of these settings, it's going to keep these, it's going to save these. So the next time you import a model, it's going to build Nanite, it's not going to create materials, and it's not going to import textures. All right, so now we can come down here and we can click on this import button, and you'll see that it is now imported 2 models. That's because this FBX file contained 2 models. There was the closed version of this trunk right here. If I double click this one, there is the open version. Now, these both use the same material, the same textures. So for here, what we're going to do is we're going to come down and right click, go up to material. Just going to name this M_Jenny Lend trunk, and then go in here and apply this. So remember, we can drag and drop this on here, or we can, with it selected in our content browser, we can come up here and click this little arrow right here to assign it. Now, right now it's all black. It's because it's got nothing going on. Go ahead and open this up. And then the next thing that I want to do is I'm going to import the textures. Same thing. We're going to come back over here. I'm going to go up a level into the textures folder. I like to just drag and drop these things in. So you can drag and bring them all in at once, but there's something very specific that I wanted to show you. So if I were to drag this base color in, now we see that it's imported. We can see it right there. If I were to drag this normal map in, we can see a little pop-up that says texture was imported as normal map. We'll hit OK on that. That is something really cool that Unreal automatically does, is if you have a normal map that has your traditional normal map colors in it, Unreal is able to read that and automatically set it to a normal map in the compression settings. Now, why is that important? Well, that's because the compression settings determine a lot about a texture. And we're going to look at that with the third texture in here, which is the occlusion roughness metallic map, or the ORM. If I were to just drag this into here like this, there we go, get this guy out of the way. Now, this right here is one of those instances where we are going to be using individual channels from this. So if we look at the red channel, this is our ambient occlusion. The green channel is going to be our roughness. And then the blue channel is actually going to be our metallic map, where we can see the black areas are things that are not metallic, like the wood or the leather. And the white areas are things that are metallic, like the brass. Now, something to keep in mind with these textures is that these textures go through a process called gamma correction. Now, what that means is that in gamma correction, it takes the compiled RGB of the image and then it gamma corrects it to the sRGB color space. Now, if we want to use individual channels of this texture, that gamma correction, that changing it to the sRGB color space, is going to mess up those individual channel values, so we can't use them in the way that we want to. So whenever we're working with a texture that we plan on using individual channels, we need to turn that off. Now, there are a couple of different ways that we can do that. Over here in the details panel, we come down here to texture, we see this sRGB and a checkbox. We can actually uncheck this and it'll turn off that gamma correction. Now, you may not notice a difference when looking at it, but that difference is there and it is enough to make a difference in your individual channels. But I will turn this back on, and the preferred way to do this is to actually change your compression settings. So if we go up here under compression, we see compression settings, and we see by default it is set to default. Just like if we were to come over here and open the normal map, we can see that the compression setting is set to normal map. Well, for this guy, what we want to do is we want to set the compression settings to masks. And what the masks means is it means that you are intending to use the individual RGB channels and not the combined RGB color. So we will change it to this. We'll see that it
changes the sRGB to off. And there's a couple other things that happen, but this is going to work for us for now. So go ahead and save this. And then we can go back into our material, and I'm just going to drag each one of these in just like that. And then something else that we can do really cool in the material editor is over here in our viewport. If we were to come down and select this static mesh down here, the open version of this, I can actually come up here to the viewport in the material editor and click on this little cinder block looking icon, which is going to tell it to use the mesh that I have selected in the content browser in the preview. So now this makes it a little bit easier to work with this material in here. All right, so with that, what I'm going to do now is come over here. I'm going to plug in my RGB from the base color. I'm going to plug in the RGB for the normal. And then we can see over here that we now have these textures on this. If I start working with my masks, if we remember the O for ambient occlusion, we'll drag off of the R, O and R, to the ambient occlusion. And then green is the roughness, the R. So we'll drag that off and bring it into roughness. And now we can see some things going on over here. We can see that we've got a little bit of shininess here and there. But we also have metal and non-metal parts to this, which are stored in the metalness map in the blue channel. So we'll drag off of this, plug it into metallic, and now there we go. Our metallic pieces are metal, our non-metallic pieces are not metal. I can go ahead and hit apply. And then if we look down here, we can see that both of these, since they have the same material and they're using the same textures, the same UVs, both of them are now all set up and good to go. So that is how you import a custom asset. You import the models, you import the textures, you create the material, you assign the material, and then from there, you should be good to go. All right, now you know how to import custom 3D models and textures. If you're a 3D artist yourself, you now have the power to render your work inside of Unreal. This can actually be a replacement renderer for things like Marmoset Toolbag for getting your work up on your portfolio. Now, if you're more attuned to the layout artist route, then this can help you when working with other artists on a project. All right, so Unreal Engine projects are basically packaged containers full of assets that are wrapped up in a file type called UAsset. Now, all of your FBX models and PNG textures that you bring into a project are all converted to this UAsset type when you import them. And while you can technically export models and textures back out of the engine, there is still a lot of files in your content browser that are Unreal Engine specific. In this video, I wanted to show you how to migrate these Unreal specific UAssets between Project A to Project B. Let's get started. For this exercise, I've provided you with a small pack of custom assets from one of my personal projects that you can use to practice this with. Now, you're also free to practice this process with any Unreal Engine projects you may already have. All right, let's jump right in. All right, here we are. I have two Unreal Engine projects side by side. On the left, I have my working project that I'm working in. And on the right, I have a project that has some assets in it that I want to migrate over to the working project. Now, this is actually really easy to do. So what I'm going to do is go in here under my content. I'm going to go into this LDA assets folder and go into this prefabs. And I've got a couple of blueprint prefabs that I've gotten here, such as this BP_ magic bottle. If I drag this out into the world, you can see what that is. Now, if I want to get this over into this project, it's actually really easy. All you have to do is right click on this, and you're going to go up here to Asset Actions. Then we can come down to Migrate. And I'm not going to save this map here. But once you select Migrate, it's going to give you your asset report, which is going to show you all of the dependencies that this particular asset has. So this blueprint prefab here, you can see it right there. It has my Magic Bottle 01 static mesh, which has the M_magic bottle material applied to it, which uses these 4 texture maps in here.
Now, when I migrate this one asset, it's going to migrate all of this stuff with it, and it's going to keep its folder structure. So what I'm going to do now is I just click OK, and then where this takes me is the content folder of the Unreal project that I'm currently in. So what I need to do now is find the content folder for the project that I want to migrate to. So that would be up here in this. I'm going to go into this one right here. And this is the very important part. You cannot skip this. You have to do this part right. You need to go not only into your project, but you need to go into that project's content folder in order to migrate it. Once you've done that, you're in the content folder, you hit select folder, you'll see that. And then now over here in this project, you'll see that it's added this LDA_alley assets folder, which let me go ahead and maximize that. And in this, we have the prefabs folder, which has my magic bottle here. And of course, we have the props folder with the mesh in it. We have the materials folder with the actual material applied. And we have the textures folder that has those textures for that mesh. And only that stuff. So if we look back over here, this folder has a bunch of other stuff in it. Let me go into the props here. And you'll see this load up, but we have all of these cloth projects, the crate and barrels, all of this stuff in here. And none of that got migrated. It was only this magic bottle blueprint prefab that got migrated because that's the only thing that we selected to get migrated. Now, if I wanted to migrate all of this stuff over, I could go to this folder, go up to content here, and I can actually right click and go up to migrate, and I could migrate everything in this folder over to that project. So I'll click OK, and it is still in the content folder of my other projects. That's where I navigated it to. It saved that spot, but this is my first Unreal project over here. Content folder, I can hit select folder. It's going to move everything. And what we're going to get here, we get this little message that says an asset already exists at that location, referring to the magic bottle asset that we've already migrated. Now we could click yes to all and let it overwrite it because we haven't actually changed anything. But also we already have it in the project, so we don't need to overwrite it. So I can hit no to all on this, and it'll leave the previous version that we migrated before in there. Now, if I were to go into this props folder, we can see all these other meshes that have now been migrated in here, along with their materials, their textures, and all of that. So if I were to go into this prefabs folder here, I now also have my lantern, which I can bring out, which this is just a blueprint prefab that I set up that happens to have the ability to toggle the light on like that, or toggle it off. And if I were to go up here to my directional light, I'm just going to turn off Affect World real fast. There we go. Now it's all dark. Can go back to my lantern, toggle that light on, and you can see what these are doing. So you can see that all of the functionality that was included in the blueprints for these also copied over when we migrated them. One last thing I wanted to mention on migrating between projects is that you can go up a version, but you can't go down. So for example, let's say you want to migrate from a 5.0 project into a 5.1 project, you can do that. Unreal will automatically upgrade your U assets for you. However, you cannot migrate from a 5.1 project down to a 5.0 project because the U assets will not downgrade. All right, now you know how to migrate assets between projects. This is useful for if you need to move some old work to a new project, or you need to migrate something from a marketplace project, or even if you just want to clean out a working project by migrating just the good stuff into a fresh project and then leaving the rest behind. It's all a very useful process. Now, one question I get all the time is, how come my normal map doesn't look right when I import it into Unreal? And I don't just get this question from my students either. I've actually gotten this question
in production from my senior artists that have come to the project from another rendering or game engine? And the answer is always the same. They're using the wrong normal map format. Now, there are two ways that a normal map can be rendered: OpenGL and DirectX. OpenGL has been a popular normal map format since the inception of normal map technology. It's very easy to read with your eyes. It's the WYSIWYG of the two formats, really. What you see just makes sense. Cracks, grout, and other crevices look indented, while bumps and protrusions appear to stick out. When you look at an OpenGL normal map, you immediately know what you're getting. This is what your 3D modeling package likely uses, and most texturing suites support it. But Unreal Engine uses the other sibling format for rendering normal maps: DirectX. At first glance, a DirectX normal map can just look wrong. It's not instantly easy to read like OpenGL is. It almost comes off as backwards. Cracks and crevices are actually sticking out, while protrusions are indented. But alas, this is the format that Unreal Engine uses. Alright, now you know what your normal map should look like in order to render correctly, but you're still asking the question of, what if an asset I'm using has an OpenGL normal map? Well, to solve that, we need to understand what the difference between the two formats is, and that difference is in the Y, or the up direction. In a normal map, the R, G, and B map to the X, Y, and Z. In OpenGL, the lighting information in the Y, or the green channel, is coming from one direction, while the lighting information in the Y direction of a DirectX normal is coming from the inverse direction. So you can literally switch formats by just inverting the green channel. In the industry, we call this flipping the Y, or flipping the green. Now, you can permanently alter a normal map by inverting the green channel in Photoshop and resaving it out, but you can also do this non-destructively inside of Unreal on the config of a texture. To change an OpenGL normal map to DirectX inside of Unreal, just open up the texture, go to the Details panel, and search for Flip Green to find the Flip the Green Channel checkbox. Now, Unreal will treat your OpenGL normal as if it were DirectX. So if your normal maps just don't look right inside of Unreal Engine, check your normal map format. And if you have the wrong format, now you know how to fix it. Alright, so we know how materials work inside of Unreal Engine, and we know how to get around the material editor. Now we want to explore how efficient Unreal's material system can actually be by getting familiarized with the concept of material instancing. Material instancing has two core components: the master material and the material instance. Let's break it down. Starting in reverse, a material instance is a collection of parameters that you can edit to achieve a specific result. We can see an example of this if we open up one of our Megascans materials that we've downloaded. On the right, you can see here a list of settings that we can change the values of. On the left is a viewport where we can see the results of those changes. Now, a master material is the master that contains all of those parameters that can be edited. This is basically just a standard material where the editable nodes are converted to parameters. For every master material, you can have an infinite number of material instances, all with different settings. Let's dive in and make our own example. We'll start by creating a new folder in materials called Instance Demo. Inside of here, let's right-click and create a material. We'll call this MM_MyFirstMaster, where the MM stands for Master Material. Double-click to open, and then we're going to create a color node by holding down 3 on the keyboard and left-clicking. We'll plug this color node into the base color. Pick a color you like, and then hit OK. Now, we'll right-click and select Convert to Parameter. We'll name this new node Color. Next, we'll hold down 1 and click to create a constant. Right-click and convert it to a parameter, name it Roughness, and then plug it into the roughness slot. We'll then go over here and set the default value to 0.5. For slider min and max, we want to set that to 0 and 1. Now we have a basic master material with 2 parameters. Next, let's create our first material instance. In the content browser, we'll right-click on our master material and click Create Material Instance. We'll name this MI underscore instance 01, where MI stands for material instance. If we double click to open our new material instance, we'll see the two parameters that we created. Now, to edit each of these parameters, we have to check the checkbox next to them. This activates them and makes them available for edit. Now we can see that we can slide the roughness value and see it change in real time. Same with the color. If we activate it, we can click on the color swatch to open the color wheel, or we can change the color. Take note that the color parameter, which is a vector parameter, has a drop-down arrow next to the name. This allows you to update the values for the individual channels. Artistically, this makes it easier to achieve a pure red, a pure green, or a pure blue value. But where this is most useful is when you're using a vector parameter to store individual values. In a sense, you're gray packing in shader math. We'll get into that later. Now I want to direct your attention to the fact that these two parameters are located within different categories based on the type of parameter that they are. The roughness is categorized under scalar, which refers to a single channel constant value. And the color is categorized under vector, which is a multi-channel value. For a friendlier user experience, you would generally want to categorize these within custom groups. Luckily, Unreal makes that really easy to do. Let's go back into our master material, select a parameter, and then over here in the details panel, you'll see an option called Group. If you check the drop-down, the only option we have available is None. To create a new group, we can actually just click in here and start typing. Let's create a group called Settings and hit Enter. Now, if we select our other parameter, we'll see that our Settings group now exists in the drop-down for us to select. Hit Apply, and then we'll check our material instance. Now you can see that both of our parameters are grouped together nicely under a category called Settings. All right, let's look at adding a metalness option to this material. For this, we want to plug a constant scalar value into the metalness slot on our material. But remember, in our PBR lesson, we discussed that a surface is typically either metal or not metal, meaning it should really usually only be a value of either 1 or 0. Let's make that easy for ourselves and our users. We're going to do that with a node called the static switch. Let's come into our master material and we'll right-click to bring up the node menu. Type in static switch and find the static switch parameter. Now, we want to make sure that we select the parameter option so we can edit it in our instance. We'll call it isMetal with a question mark. You'll see that this node is a Boolean value, an if-else statement where we have a true and a false. First, let's give this statement some values. Hold down 1 and click twice to create 2 constant scalars. Now, we won't be converting these to parameters because we won't be editing them directly. Instead, we'll use the switch to toggle between them. So let's think about this. The question is whether or not this surface is metal. So if true, we want to feed in a value of 1 for yes, because a metallic value of 1 means that it is in fact metal. And if false, we want to feed in a value of 0. We can then plug this node into our metallic slot. Note that this default value here that lets us define whether the default value is true or false. And in this case, we'll leave it as false by default for now. Make sure to set the category to settings and then we'll hit apply. Now check the material instance and we'll see a new parameter. We need to check the box to activate it and make it editable. But then we'll see that we have a checkbox that we can use to toggle whether something is metal or not. All right, let's test this process out. Create a new basic level. We'll add a few spheres. Then we can duplicate our material instance a couple of times by hitting Control D. We'll apply a different instance to each one of the spheres. Then we can proceed to go in and change the settings on each instance. We should see all of these updates happen in real time in the world. This process allows us to have one single master material with defined controls and then have multiple variations of those settings. Master materials and their instances are one of my favorite features of Unreal. It may not seem like much at first with a simple material like this, but it can save so much time and, most importantly, helps maintain consistency, especially when you're working on a team. Now, I've personally been on production projects where we have had complex master materials that had over 100 different settings. But even using this process, the simplest of materials can save you so much time over the course of a project. All right, so we've explored the asset pipelines and the visual aspects of Unreal Engine. In this module, we're going to dive into some more of the technical aspects of Unreal. Blueprint. Before we get started, we need to answer the question, what exactly is Blueprint? Blueprint is an actor type inside of Unreal that is one of the engine's most powerful features. It allows you to do something as simple as create prefabs all the way up to creating gameplay features with visual scripting. Let's have a quick look at the Blueprint UI. As an example of how powerful Blueprint is, there are many different types of blueprints that you can create by default. You can see this in Unreal if you go into your content browser, right-click, and go up to the Create Blueprint button. You'll get a little pop-up with a ton of options, but in most cases, you're going to be using the first one. Actor. If I open up this new blueprint, we'll see the Blueprint Editor interface. It has a similar layout to other editor interfaces that we've looked at before. On the far left, we have our Blueprint Controls section. On the far right, we have our Details panel. And then in the middle, we have our Stage. Below the stage, you'll see the Log section, which will show you your errors and your message log, as well as give you options for searching and finding references. All stuff that we'll dive into deeper later. Above the stage, we have our breadcrumbs and tabs, which will become very useful in the next lesson. And then above that, we have the toolbar. Diving deeper on the left side, our control section is split into two tabs. The Components tab is the equivalent of our Blueprint Actor's outliner. Just like the outliner in the level editor, this is where you'll find a list of all of the components in your actor. Below that is the My Blueprint section, which is the command center for all of the scripting aspects of Blueprint. Back to the middle here, the stage area is a very dynamic area. Here, you can see a 3D viewport. A blueprint allows you to have pretty much any actor you could have in a level exist inside this self-contained world. We'll talk about that more in just a minute. But first, I want to look up at the tabs above the staging area. You'll see 3 tabs by default: Viewport, Event Graph, and Construction Script. Now, you've seen the viewport, but if I were to switch over to the event graph, you'll see a different UI that is similar to that of the material editor. This is where we do the actual visual scripting part. The construction script looks very similar to the event graph and is also an area for visual scripting. So what's the difference between the event graph and the construction script? Well, it's all in the names, really. The event graph is all about events, both creating events and reacting to events. This is where dynamic gameplay happens. It's important to note that the event graph runs while the game is actually being played. So generally, to test something happening in the event graph, you need to drop in and play. The construction script happens on construction of the blueprint actor in the world. To understand this, you need to really understand when construction happens. The construction script is run anytime the blueprint actor is added to a level, moved around, or a parameter is changed. It's also run whenever you first begin playing, as well as if it were dynamically spawned into the world. The coolest thing about the construction script is that since it is run when the actor is first added to or moved within a level, it also runs an editor, so you don't have to drop in and play to see the effects. You'll see how cool this is a few videos from now when we explore creating dynamic prefabs. But on the subject of prefabs, let's walk a couple steps back and look at a simple use case scenario for Blueprint. Using a blueprint as a prefab is a fairly simple implementation. Think about our crates and barrels from before. We arrange them in a specific order for a scene, but if we wanted to have that particular arrangement be saved as a prefab that we can just drop into other scenes, then we can actually do that really easily with Blueprint. Let's give it a try. All right, the first thing I'm going to do is I'm going to come in here and right click, go up to the Blueprint class button, and then I'm going to select this first one called Actor. I'll type in BP underscore crate barrel. Then if I were to open this up, we'll now navigate over to find my crate and barrels, and I will drag this barrel here to the components and drop it on this default scene route. And now we can see the barrel in here. So if I were to then click on this and Control D, I can create a duplicate of it. Now I can drag this duplicate around inside of my 3D editor here. I can also then click on this default scene route to make it active again. And I'm going to drag and drop this crate in here just like that. Now I can click it inside of here and I can drag this around just like this and position it like that. I could then Control D to duplicate it again, select it from the components over here. And now I can move this over here, Control D to duplicate it again. Going to bring it up here just like that. Maybe rotate this around some, move this barrel up, and we could continue to go through and arrange these in any way that we wanted. Then, when done, we'll hit compile. Going to minimize that down a little. I'm going to click on this button here to browse to my original blueprint asset. And if I were to drag it out into the scene, there we go. Now we have this blueprint prefab right here that we can treat pretty much as a group. Then I could alt drag a copy of this out. I could drag from here to bring another one in. So this allows you to arrange a certain set of models together in a prefab format that you can then drag and drop however you want to. Blueprint also offers a visual scripting solution inside of Unreal that uses a node-based workflow to add functionality to an Unreal Engine project. Basically, it's visual code. Unreal Engine is built using the programming language C++, and as a developer, you actually have access to the source code. You can modify the source code, or you can extend it with your own C++ code. But this isn't the only way to add functionality, and it's primarily useful in more advanced level development projects. Blueprint actually gives us a visual coding option that is more artist-friendly at its base, but it also offers a lot more power to those who are familiar with programming fundamentals. Blueprint uses what is called flow control to guide the order of events. The nodes are connected by strings to tell the actor what to do next. It's very similar to the material editor and how nodes work there. Just like in the material editor, nodes can have inputs as well as outputs, with the addition of an input-output slot called execution. This execution controls the flow and tells the operation where to go next. Let's have a look. To show how this works, I'm going to right-click, go up to Blueprint Class, click on Actor here. I'm going to call this BP underscore basic flow, just like that. I'll open it up, and what I'm going to do is over here in my components, go to this add button. I will click on that, and I'm going to come down and add a cube. That's going to add a cube into my viewport here. I'm going to lift it up just a little bit so it's actually sitting on the floor. And then I'm going to come in here, click on my default scene route, click the add button, then come down and click on this sphere. It's going to add a sphere component in here, which I will then move up here just like this. And we can see setting it at 140 here is going to set it like right on top of this cube. Now what I want to do is I want to actually move this up 50 centimeters from this. So 140 plus 50 is going to be 190. How I'm going to do that is go into my construction script here, and I'm going to drag this sphere out here into this, and then drag off, and I'm going to type in set relative so I can get this set relative location. Now, how this works with the flow is we come out of this execution and we plug into this one. So on construction, it is going to execute this
relative location change onto the sphere. And for this Z, I want to put 190 because 140 plus 50 is 190. I'll hit compile. And then if I were to drag this out into the world, we can see that this sphere is now floating above it. Looking back in here at the graph, what's happening is this flow is going from this node, following this string into this node, and doing exactly what we tell it to here on the target, which is our sphere. Now, that was a fairly simple example of using the visual scripting aspect of Blueprint, which is a much deeper subject that we'll start to explore throughout this module. For now, you should have a little more familiarity with what Blueprint actually is. You can use it for the simplest of things like prefabs, and you can use it for some very complex gameplay elements or editor utilities. Is the game engine learning curve holding you back? I get it. Learning Unreal Engine is hard, but it doesn't have to be. Rendering technology has advanced so much in the last 20 years that it's almost been hard to keep up. But there's one tool that's been defining the future of 3D for a while now. From video games to film and television, Unreal Engine has been dominating the entertainment world and is quickly becoming a tool that anyone working in 3D needs to have in their tool belt. That's why I founded Learn Digital Alchemy and developed the Unreal Engine Pro Masterclass. But if you opened up Unreal and found yourself completely intimidated, no idea where to get started, so you go to YouTube and just find yourself even more lost from the endless pile of disorganized videos. With the streamlined curriculum of the Unreal Engine Pro Masterclass, we'll go on a journey together to help you quickly get comfortable navigating the software like a pro. In fact, we'll get you up and running in Unreal Engine in just 1 hour for free with the first module of the Getting Started section of the course. In my world, using Unreal is just another basic skill that I feel like everyone should have, like walking the dog or doing laundry. So this first module is completely free, no strings attached. And I'm not even going to ask you for your email address to get access. But let's say you already know the basics. Have you tried following tutorials online that walk you through step by step to create a result? But then, when you try to create on your own, you find yourself completely lost without the hand-holding. In the Unreal Engine Pro Masterclass, you'll learn the foundational building blocks that form the basis of everything you do in Unreal. You'll get comfortable with the how and the why, so that when it comes time to do it on your own, you'll know exactly what steps to put together in what order to reach the result that you want. I like to look at it from a perspective of small foundational Lego blocks that are put together in different combinations to reach different results. It's like a collection of ingredients put together in different amounts and orders to create different menu items. In the Unreal Engine Pro Masterclass, we learn the small steps first, then we put them together in different ways to accomplish different results. Then, your challenge is to use these same building blocks to accomplish the result that you are after. By that point, you should have no trouble doing just that. But, of course, if you're still struggling, just ask. You'll have access to me, as well as some of my colleagues and other students, both past and present. But who am I? My name is John Wainick, and I'm an Unreal Authorized Instructor. That basically means that Epic Games, the creator of Unreal Engine, relies on me and other Unreal Authorized instructors like myself to help develop education that teaches students the right way to use Unreal. But even while doing this, I still work in the industry, and I have for a while. I spent some time in the virtual production space, leading teams that build digital sets that go up on LED volume walls, which is a technology that lets you do in camera what used to have to be done in post-production when filmed against a green screen. I've been using Unreal Engine for games professionally since Unreal Engine 3, and most recently have been at the forefront pioneering the AAA game industry forward with Unreal Engine 5, including using some of the most advanced rendering tech you would never imagine you'd ever see in a mass multiplayer online role-playing game. Let's look at some of the top myths about the Unreal Engine Pro Masterclass. Unreal Engine is just too hard to learn. I've been teaching students how to use Unreal Engine for over 10 years now. I've discovered some of the best techniques for learning this powerful software fast, but more importantly, I've discovered some of the worst ways to learn and
how to avoid them. With the streamlined curriculum of the Unreal Engine Pro Masterclass, you'll get that 10 years worth of proven learning techniques that I've used to help so many jumpstart their careers in both game development and virtual production. My methods have even helped students use Unreal Engine to get them jobs at studios that don't even use Unreal. I'm already taking a live course in Unreal Engine. That's awesome! I won't deny that nothing beats live mentorship when it comes to computer graphics. In fact, I still teach live classes at various schools myself, but the Unreal Engine Pro Masterclass is not really in competition with live education. It can very much fill a supporting role to help accelerate your learning process. Why waste valuable class time asking questions about basic Unreal usage when you can just refer back to one of the Masterclass lessons that will answer it for you? That way, you get more value out of the time spent with your mentor asking the questions that matter more. In fact, one of the reasons I created the Masterclass in the first place was so that I had something I could point my own live students to when they had a basic Unreal question. And of course, the students that took the extra time to go through the Unreal Engine Pro Masterclass actually had an almost unfair advantage over their classmates. So sign up today and start becoming an Unreal Engine Pro. I'll see you there.